In this video, we're going to look at the concept of an inverse function, or inverse functions. We're first going to start off with the definition of an inverse function, and then we're going to look at an example of how we're going to find the inverse of a function. But before we do that, let's get an idea of what inverse functions are about. And so let's look at a very well-known inverse pair relationship. So if I put here f equals 9/5 c plus 32, and over here I'll put c equals 5/9 times f minus 32. Okay. Now I assume most of you recognize this because you'll have seen it from science. This is the formula to go from Celsius, to convert Celsius to Fahrenheit. And this is the formula to convert Fahrenheit to Celsius. And so these two equations are actually inverse functions of each other. And so this is just an example, and it's a well-known example, of what inverse functions are. And so if I had this formula first, and we had this Celsius to Fahrenheit, someone might ask, well, what if I have Fahrenheit? How do I get to Celsius? And the idea is, if you find the inverse function, then you create a formula to go backwards. So we're not going to say which way is forward or which way is backwards, but what inverse functions do is they allow us for us to go one way, and then we get the inverse function, and we can go back. And so this is the general idea of what inverse functions are. All right, so now let's look at the definition of inverse functions. All right. So this definition is actually kind of difficult to understand, and but once we get the definition done, we'll go through some examples, and finding the inverse of a function isn't too complicated. But first, the definition. Two functions f and g are inverses of each other. So let's write that down. Two functions f and g are inverses of each other if the following two things are true. F of g of x equals x for all x in the domain of g, and g of f of x equals x for all x in the domain of f. All right, so of course this is kind of a very vague definition, but in essence, if you have two functions that are inverses of each other and you take the composite of each, you should end up with x. Now this domain aspect of it we're going to look at in another video. There are some issues that we might have to deal with when it comes to domain, and that's actually going to be a very important part later on in our study of mathematics. But first we'll just look at a basic example so we get an understanding of how to find the inverse. All right, now once we have this, if we do have f and g and they are inverses of each other, then we can use a new notation to help us indicate that we have an inverse. So let's write this down. If G is an inverse of f, so if G is an inverse of f, we can then denote G by f inverse. And the way we read this is we say f inverse. Right. So once we know that G is an inverse of f, we'll be able to write f inverse for that particular equation. All right, so let's go straight to an example. This helps out a lot. So for this example, we want to find the inverse of f of x equals 2x minus 1, and then we're going to graph f of x and its inverse. And we'll do that on the same graph. All right, so let's look at the process. And there are basically 4 steps that we need to perform in order to find the inverse. So we start with f of x equals 2x minus 1. And step 1, we're going to replace f of x with y. So that's easy enough. Here's f of x, we replace it with y. Y equals 2x minus 1. Step 2, we're going to interchange x and y. All right, so that step is also fairly straightforward. Everywhere there's a y, we're going to put an x. Everywhere there's an x, we're going to put a y. So we're going to have x equals 2y minus 1. Step 3. So step 3 is we're going to solve for y. If there is a challenging step in this, well, of course, the first thing is you got to remember all these steps. But if there is a challenging part to finding the inverse, it's going to be this step. Because a lot of times, once you interchange x and y, depending on what the equation is over here, it can be difficult to solve for y. I think for the most part in this section, the homework that you're given, it's not super challenging. But if in future math classes you actually have to find the inverse, sometimes it can be a little tricky to figure out how to solve for y again. But this one's not so bad. We'll add 1 to both sides. So we have x plus 1 equals 2y. And then we'll divide by 2. So we end up with y equals x plus 1 over 2. And if we wanted to, we could also rewrite that to be 1/2 x plus 1/2. Both of those are exactly the same. Right, now that you get this part, then step 4, this one's easy again, we're going to replace y with f inverse of x. Because once we've solved for y, this is the inverse of this original function. So we end up with f inverse of x equals, I'm going to use this one, 1/2 x plus 1/2. And there is our answer. So 4 basic steps. I don't think it's too difficult to remember the steps. But again, if there's going to be a challenging part, it's at this moment where you have to solve for y. Depending on what the equation is, that could be a little bit of algebra that you have to go through. All right, so next we got to get this graph of the inverse. So let's go ahead and get a new piece of paper. So we have two, I'll write the functions down again. We have f of x equals 2x minus 1, and we have f inverse of x equals 1/2 x plus 1/2. So there's our two, the original function and its inverse. So let's see here. I'll try to be fairly accurate. One. So our original function is 2x minus 1, so that's just a line. So we go down to -1, there's 1 point, and we have a slope of 2. So up 2 over 1. 2 over 1. And so it looks like it's going to look something like this. So there's our original function. Now we got to do this other function, which is 1/2 x plus 1/2. So the y-intercept's 1/2, and we go up 1 over 2. And so and there's our inverse. So here's what a lot of the problems are going to be like. You're given a function, let me come back over here. You're given a function, you want to find the inverse, so you go through these 4 steps, and then you graph the original and the inverse on the same graph. Now one thing I do want to point out, so here's a big old note. And this has to do with the way the notation works. F inverse of x does not equal 1 over f of x. So if you remember back in exponents, if I had, say, 2 to the -1, we would say, oh, that's 1/2, easy enough. But in this case, this is not being raised to the -1 power. This is indicating an inverse. So that's something that you have to understand about this notation, even though it looks like this. You know, if f of x is 2x minus 1, then 1 over f of x is actually 1 over 2x minus 1, and that looks nothing like our final answer of 1/2 x plus 1/2. So we can see that they are not equal. If you did want to say you wanted the reciprocal, so this is actually the reciprocal, this is the inverse. So if you wanted the reciprocal, so the inverse is this. The reciprocal would be, you'd have to put parentheses around it and say f of x to the -1 like that. So just something to keep in mind when it comes to the notation. Alright, so in this video we looked at inverses, kind of a very well-known example of an inverse. Here's the definition. We still haven't worked with the definition too much, but we will in other videos. We went through the process of finding the inverse, and there's these 4 steps. And we ended up graphing the inverse.